welcome everyone to this tutorial about students' t-distribution. T-distribution was developed by the English statistician William Gossett under the name student. So we can call it t-distribution or student distribution. And the shape of this distribution is very close to normal distribution's shape. However, we have here a wider curve and fat tails. And the reason behind that is the variance is unknown. So we accept a larger dispersion for the data. So if you look at the normal distribution curve, you will find it tighter with no tails, while the t-distribution is wider and have fat tails. T-distribution is used when the sample size is small, something like 10 observations. Students' t-distribution is used when the sample size is small and the population's standard deviation is unknown. So when we say sample size is small, is less than 30 observations. And because practically there are too many situations when the sample size is small and the population's standard deviation is unknown, students' t-distribution is considered a great leap in statistics because it has provided an efficient solution for these cases. We have many situations when the sample size is not so large and the variance is unknown. To use t-distribution, there is an assumption that the sample data is normally distributed. Therefore, we should collect a large enough sample size as we can, at least 30 observations. And the reason behind that is to get as close as possible to the actual values. Because as you know, that the larger the sample size, the closer the sampling means to normal distribution. And this is the formula to calculate the confidence interval by using t-distribution. It is almost the same the one that we used in normal distribution. But here, instead of z, we are using t value. And you are going to see how to obtain t in the next slide. So we are getting t from a t table. And n-1 is the degree of freedom. N is the sample size. So when the sample size equal 10, degree of freedom equal 9. And alpha by 2, because as we said in confidence interval, we have two sides, upper limit and lower limit. And instead of sigma in the previous formula, we are using S as the sample standard deviation because population standard deviation is unknown. And square root of n means square root of the sample. And this is an example for the t table. Let's say you want to calculate the confidence interval at 95% confidence level. So based on that, alpha equal 0.05 and we divide 0.05 by 2, we get 0.025. So exactly as we did in Z table. However, here we have degrees of freedom. When the degree of freedom is 9, we need to go to the right till we reach to the point under this value, which is 0.025. So based on that, t value here is 2.26216. And we are going to see how to calculate the confidence interval in Excel in the next tutorial. So stay tuned.